Good day. I am Keisha Gasal and I am going to explain problem number 2 in our C41 Love Activity 5. So, for our beam shown, we have our length from A to B, which is 10 feet. From B to C is equal to 30 feet. And from C to D, which is 15 feet. We have two supports, the roller support in A and our pinned support at B. Also, we have our uniform load, which is 2 kips per feet. So, given that we have to take EI as constant, our E is 29,000 KSI and our I is 1,500 inch to the fourth. First, we are going to classify if the structure is statically indeterminate, stable, or unstable. First, we are going to classify if the structure is statically indeterminate, stable, or unstable. So, drawn here is our first body diagram. We can see in our diagram that we have two internal forces, three reactions, which are AY, DY, and DX. One is located in our roller support in A and the other two is located in our pin support. So, by calculating, we can get 6 is equal to 6. Since our unknown is equivalent to the number of equations, therefore we can say that our structure is statically determinate. Next, we have to identify the support reactions present on our structure. So, our free body diagram, here we have three reactions, the AY, DY, and DX. And our uniformly distributed load here at the top, 60 kips. And since we have to find only one reaction at A, so it is convenient if we moment at D. So summation of moment at D is equal to 0 clockwise positive. So AY times the length of B to C, which is 30, minus kay clockwise man, minus 60, which is our unit load, times 15, ang atong gi-assume nga distance, is equal to 0. So our AY here is equal to 30 kips upward direction. Our assumed direction is correct. Next, we have to get our vertical reaction at dy. So we have to calculate the summation of forces along y is equal to 0 upward positive. So our dy plus 30 ang atong B to C distance is equal to 60 ang atong load. So our dy here would be 30 kips upward. For horizontal forces, we have the summation of forces along x is equal to 0, going left positive. Since we don't have any horizontal given, then automatic our dx here is 0. Lastly, we will use the virtual work method to determine the vertical deflection at joint C. So by vertical system, we can get our support reaction. So here is our free body diagram of our virtual system. So summation of moment at D is equal to 0, clockwise positive. So AY times 30, which is our length, is equal to 0. So calculating our AY here is 0. So here. For our vertical forces naman, summation of forces along Y is equal to 0, upward positive. So dy minus 1 is equal to 0. So our dy here is equal to 1 kip in upward direction. So for summation of forces along C is equal to 0. So dx times 15 atong gi-assume nga distance is equal to 0. So our dx here is 0. Next is we will calculate the internal moments in real and virtual system. So for our segment AB, we have our summation of internal moment at segment AB, which is 0. Next is summation of internal virtual moment is equal to 0 counterclockwise, in which our virtual moment in AB is equal to 0. So moving on at segment CD, our internal moment in the real system and the internal virtual moment are both equal to 0 since no other forces are involved. So at segment BC, we can see our free body diagram here. So summation of internal moment sa atong real system is equal to 0 clockwise positive. So since nag-cut man tag distance, our MBC here is equal to 30 times x, ang lahat niya itong giasyong distance, minus 2 times x over 2 since half man atong gikat for segment BC. Here we can get our internal moment sa ato ang real system is equal to 30x minus x squared. Next is we will calculate the summation of internal virtual moment, which is equal to 0 clockwise positive. So ang atong MBC is equal to 1 times 1 kay half man, so same value, which is 1 times 1 gyapon. So cancel different signs. Our MBC here is 0. Finally, we can make our table, which is present here. Present here is our 3 segments and values atong internal moments. Sa small m, our small m here is sa virtual system nga internal moment, and our capital M, which is sa real system nga internal moment. So with the values calculated, shown in our table, we can see that the internal moments are 0. Therefore, the vertical deflection at C is equal to 0. That's all. Thank you.